We're going to continue our work with functions. I just want to remind you of our definition of a function. And this states that for every value of x, there is only one value of y. And when we are looking at equations, it is important to know if they are a function or not a function. And sometimes we're going to be able to identify those, or they will be identified for us. I have an equation. I'm going to just cover up the other one. So right now I have this equation, y is equal to 3x minus 7. And if I graph this, I have a line, and I know that this is a function. Because I know it is a function, I'm going to write it in a different form. I'm going to write it as f of x is equal to 3x minus 7. And I want you to note that all I'm doing is I am writing it in a different way. It is the same thing. But when I use the f of x, this is showing me that it is a function. And this is what we call function notation. So just to give you an idea again, when I write something in this form, it's function notation. I liken it to the fact that it means the same thing as y equals 3x minus 7. So the y and the f of x are the same thing. They just look different. We've talked about this before. We've talked about the fact that we can have a value that's the same and it just looks different. So that could be like what I look like right now. Right now, probably haven't seen me looking like this. I've just come in from a walk. I have my toque on, and I'm not wearing my glasses. And usually you see me dressed up with glasses on. So I'm still the same person. I just look differently. So that's the same thing that's going on here. It looks different, but it's the same thing. More importantly, what this is telling me is this is a function. So when I see something in function notation, that's what it's telling me. Now, typically, we use triads of letters in math, and this is no different. So here I had f of x represent a function of x, and just a reminder again, this is saying this is the y. Well, we often use letters that go together. So you will also see maybe g of x. Well, guess what? That's also going to be representing a y. It's just naming it differently. And then the one that's actually more common than either one of these would be something like h of x. And the reason why we see this because it applies to what we might be looking at in grade 11. And a lot of times we'll be using this because this is going to represent height. Now, sometimes you're going to see it that it doesn't always have an x. I could have h of t. And what that is going to represent is that the x value is a t, right? So my independent variable would be t, and the h of t is the dependent variable. And we're going to explore that a little bit more in this section. So for now, I want to look at what is happening when we're looking at a function. So we're using this kind of like an input-output device. So we're going to put in a number into the function. We're going to put a 2 into the function, and it comes through this machine, goes clickety, 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 clank, and out comes a 4. So when a 2 goes into the function, a 4 comes out. All right, so I'm going to write that as an ordered pair. 2, 4. So we know what happens. Well, what about if I put a 3 in this function? A 3 will go into this function machine, go clickety, 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 clank, and out comes a 6. All right, so there's a 3, and then 6. All right, another number. Let's put a 7 in. So a 7 goes into the machine, clickety, 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 clank, and out comes 14. And then we could say, what is happening here? What function is taking place in this machine? You can look at the ordered pairs to determine what that function might be. That's what's happening. It's performing some sort of function. And in this case, the f of x, the function that is taking place, is 2 times the value of x. So that when a number goes in, and that number, this is our input, this is what's going in, the function f of x is the output, what comes out. And that is looking at independent variable versus dependent variable. I'm going to do another one and see, just for a little fun, I'm going to put a number in, see if you can figure out what function is being performed. So 5 is going to go into the machine, clickety, 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 clank, and out comes a 6. So I'll just record these here so you can see what's happening. Okay, what other number? Well, let's put an 8 in. 8 goes in, clickety, 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 clank, and out comes a 9. Let's put an 11 in. 11 goes into the machine, clickety, 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 clank, and out comes a 12. Do you know what function was being performed? Did I give you enough examples? Remember that for every value of x, there's only going to be one value of y. So I can put in any value because this is our independent. Just remember, input, which you would have learned probably in grade school, this is now what we talk about as our independent. That's a big long word, you can't even see it there. Versus, and then what comes out is our dependent. It depends upon what we put into the machine. So this function that I have created, the function that's being performed is it's taking my input value and then adding 1 to it. And then that's giving my output. So this is an analogy to show you what is happening with functions. So as I had already talked about, we have, for every value of x, there is only one y, and we can write this in function notation. So when we're looking at function notation, we typically have f of x is equal to something. Oh, I guess that's up a little high. I don't think you can see what I wrote there at the very top of my page. And I can't move it down, so I better move that. All right, so when we have function notation, we typically have f of x, g of x, and h of x. And these would be the function that we're talking about. Now, also we can write our h of x, I told you we could see it as h of t. So that might be something like negative 4.9 t squared. Okay, this is one we'll see a lot of in physics. And then we could have h of d. And let's say I had 0.09 d squared plus 0.9 t plus 2. So some sort of an equation that looks like that is also possible. And in each of these, the difference here is that in the d, this would be like the x. All right, so I put a t instead of a d. These are like the x's. And the h of d is like the y. So I could rewrite that as y is equal to 0.09 x squared plus 0.9x plus 2. It means the same thing. So remember, we're dealing with variables. We tend to use variables in math to represent certain things. So it helps that if I'm talking about height, I'm using h. And if I'm talking about distance, that I'm using d. So a good example of that might be the cost to rent a hall. So the cost to rent a hall, let's say it costs $150 just to rent the hall, and then we would have to charge maybe $10 a person because we're serving dinner. So this is the equation that would represent that, where n is the number of people and c is the total cost. Well, in function notation, that would be c of n is equal to 150 plus 10n. And the only thing that's different is I am saying this is a function, and this is representing my y value, right? Or the cost that we had here. And n, it's representing my x value. And that's just a different way to write an equation that we know is a function and is performing a certain way. I want to talk about syntax and what we're going to see and how we're going to work with it. I think, I want this. So let's look at how we write things in math matters. It tells us different information. So let's say that I have an equation. Y is equal to 2x minus 2. And I wrote that too high. So if I know this is a function, I'm going to write this as f of x is equal to 2x minus 2. So I'm just writing it in a different way. If I was to give the directions f of 4, what does that tell me? Well, that is telling me this. We're going to let x equal 4. In other words, I'm going to have to solve for the y value. So with my function notation, f of 4 is saying wherever there is an x, I am putting in a 4. So f of 4 is equal to 8 minus 2, so f of 4 is equal to 6. In my function machine, I go back to the function machine, I am putting a 4 into the function, and out comes the 6. That's what's happening. This is different than if I had f of x equal to 4. If I have f of x equal to 4, that's saying my y is equal to 4. So in that case, I would have to write it as 4 is equal to 2x minus 2. And I am having to solve for the x. We add 2 to both sides, and I have 6 is equal to 2x. Dividing by 2, I have that x is equal to 3. So 1 is finding the y value. So this particular example would be like finding my y value when x is 4. And this one on the right is saying I am finding the x value when my y is 4. And we are going to be doing a number of examples, and they're very similar to each other. And I am going to create an anchor chart that can help you to see the different ways in which this is written. So let's look at an example. So I have a function, f of x equals 3x. And this is how I've been saying it. This is kind of how I am saying, f of x. Right? So this is the way in which we would say this, f of x is equal to 3x, which is 3 times x. So it says find f of 4. Remember, this is saying that x is equal to 4. So in my function, f of x equals 3x, if I am going to say f of 4, that's equal to 3 times 4. So f of 4 is equal to 12. Right? When x equals 4, then y equals 12. That's what I'm finding. Okay, let's try this next one. I'm using the same function. Now I'm saying we're going to let x equal to 2. So I have f of x equals 3x. What is the value of the function when x is 2? So f of 2 is equal to 6. right? What is the value of the function when x is equal to 2? That's what I'm asking. Right? What's the value of the function when x is equal to 2? Look at another example. If g of x is equal to x squared plus x, find g of 3. So, that means wherever there's an x, I am putting in a 3. So g of 3 is equal to 9 plus 3. G of 3 is equal to 12. And if we think about this as that function machine that we had before, when I put a 3 into this function, this is our g of x function, out is going to come 12. So g of x is equal to 12 when x is equal to 3. Oops, sorry, I didn't mean to move my stand. Now let's flip that the other way. This is one where we tend to struggle a little bit. Now it says find the x if my f of x is equal to 5. So here is my function. So f of x is equal to 2x plus 1. F of x equals 5. Here's my f of x. That is 5. Find the value of x. So now I'm trying to find out what is the x. So I'm going to subtract 1 from both sides. And I get 4 is equal to 2x. And divide both sides by 2. And x is equal to 2. So, when f of x is equal to 5, remember that is saying y is equal to 5, then x is equal to 2. You need to understand what that is representing. Now let's look at this graphically, because we're going to look at this, or we can, and we will in our textbook, look at this as a graph. And so we can word this in different ways. So I'm going to start with find y when x is 3. Find y when x is 3. So you're going to read and find where x is 3. So I don't know if you can see, we have a very light amount line right here at 3. So we go up to our graph. So there's my x is 3. Find a point on the graph, which is there, and then that's saying 4. So when x is equal to 3, y equals 4. Well, we can switch that. We have to be very careful about what's being asked. What if it says find x when y is equal to, let's do a different one, when y is equal to, let's say, -4. So you go down to where y is -4 and read over to the graph. And that tells me then that x would equal -1. So one is find x, find y. We have to read to know which one we're looking for. Similarly, find the range. When the domain is -2. Oh, Well, remember what the domain is? Domain is negative 2. That says x is negative 2. All right, so my domain is negative 2, which is right there. Read to the graph to this point, and it is negative 6. So then if I know this is a function, I could say then f of x has to equal negative 6. And just a reminder, that's the same thing as saying that y is equal to negative 6. So I could ask, find the range when the domain is something, but I could flip that around and I could say, find the range, find the domain when the range is negative 2. I'll do it right there so it's easier to see. Oh, so now I'm looking at my y value. Remember, this is saying range is negative 2, says y is equal to negative 2. So where's y equal negative 2? Right there. What's the value of x? The value of x is 0. Let's look at another example. So in this particular one, how about I want to find the domain when the range is 0. When the range is 0, that means when y is equal to 0. So y is equal to 0 on this line. Oh, there it is. What do I have? The domain is 2, meaning, of course, what? That my x is equal to 2. What about, knowing this is a function, this is a function. I don't know if I can quickly even say what the function this is, but don't worry about it. It is a function, so this is, let's say this is the function f of x. Find f of x when x is equal to negative 2. So where's my x? Negative 2, right here. Up to my graph is there. Reading over f of x equals 3. So what I did was I read up there at the negative 2, there's my x value to the graph, and then reading to the corresponding point on the y-axis that says that the y is 3. So you're going to have some questions to do today that will help you to practice that. Oh. A little bit longer than I anticipated. So I'm going to stop right there, and then I will probably make a second part to this